Good morning, ladies and gentlemen. I'm Keith McGilvery. I'm the Chief Executive of BAFSA. A very warm welcome to the fifth of our webinars this year. Today we're looking at warehouses, storage facilities and distribution centres. A very important subject in the UK at the moment. It's not just about the fires in these places, it's what it does to the economy and what it does for trade. How often have we seen a distribution centre or a warehouse or even a factory getting burnt down and never reopening again, and we lose the business to elsewhere? It's all about having the competitive edge. It's all about being resilient. And today we've got some fantastic speakers talking about their experiences with warehouse fires. We have Tom Roche from the Business Sprinkler Alliance, who've carried out a large study of fires in warehouses and distribution centres for the last 8 to 9 years. We have Ian Goff, who's a technical advisor to BAFSA, and we have Alan Crichton, who's a design course facilitator for BAFSA and also chair of the BAFSA Technical Committee. So I'm certain you're going to have an excellent day today. There will be questions at the end of all the presentations, together with questions during the presentations, which will appear on screen. So please participate in these, and I look forward to seeing you for your questions at the end of all the presentations. Thank you very much for attending today.
Warehouses and distribution centres represent a key part of commerce and are an increasingly common sight around our towns, alongside busy motorways, as well as in our ports. We are all reliant on warehousing and distribution, from the food we eat to the cars we drive to the medicines we take. Businesses depend on consistent supply chains to serve their customers and grow the economy. There are many causes of warehouse fires: deliberate fire setting, discarded smoking materials, and electrical and mechanical faults being the main causes. Automatic fire sprinklers will control the spread of all fires. A warehouse fire can cause loss of expensive business equipment and stock and put the lives of staff and firefighters at risk. Fire disrupts supplies, threatens jobs, destroys businesses, and damages the environment. Install automatic fire sprinklers and increase business resilience, minimise water usage and polluted runoff water, reduce building waste and rebuild costs, and avoid the expense of maintaining firefighters on site after a fire incident. Fit automatic fire sprinklers in your warehouse to protect your employees and firefighters, and to ensure your business is resilient. Unfortunately, Keith cannot be with us for the rest of the webinar, as he is addressing councils in Scotland. Thus, it is now my pleasure to introduce Ian Goff, BAFSA's Senior Technical Advisor. But just before he begins, I would like to invite you all to post questions in the Q&A tab at any stage of the proceedings. We will endeavour to respond to them at the end of all of the presentations. Over to you, Ian.
Good morning, ladies and gentlemen. My name is Ian Goff. I am the Technical Advisor to the British Automatic Fire Sprinkler Association. Before I joined BAFSA, I'd served for just about 32 years in the fire service. And my interest in sprinklers started while I was in the fire service here in Northamptonshire. A recurring problem are large fires in storage buildings and warehouses and other similar structures. And in fact, only yesterday, here in Northampton, on the Brack Mills Industrial Estate, we had a large warehouse fire. As far as I can tell at the moment, that building was not sprinkler protected. Many of them are on that industrial estate, but this one wasn't. And it's interesting to see the words there in the local newspaper: "We'll come back stronger, say my first years." The company was known as My First Years. As a Northampton home completely destroyed by blaze. It's actually very rare for companies to come back at all after a major fire. So We'll have to see what happens with this particular company, but history tends to show us that that doesn't happen. We know that one of the main causes of fires in warehouses, we've known this for a long time, and I've just put them on the screen for those of you who are working in the industry to have a look at and consider them. But we still get the fires. And I think one of the issues is we place a lot of reliance on our fire safety legislation. And I think that's been failing us for a long time. The focus of UK fire safety laws is quite simple, really. The legislation seeks to ensure safe evacuation of all occupants from a building on fire, so the means of escape, reasonable facilities to assess the fire service in carrying out their duties to save life. That's not to actually put the fire out or to protect the building and its contents. It's purely in relation to rescue of persons in a building. And I think there's a lot to be said in this area of our legislation that needs improvement. And the prevention of widespread conflagration involving buildings beyond the one on fire. And this is legislation that really started way back with the Great Fire of London, where we try and prevent fires from spreading to other properties. Now, we've tended to do this over the years by a system of compartmentalisation. We've tried to stop fires spreading through a building with fire-resisting construction. Sometimes we achieve quite a lot with that, but often, as you can see with these large open plan buildings, we're not achieving it at all. And compartmentation rules can get quite confusing. And here we have a new version of the approved document, which is about what, the third one that we've had now. And these rules, or strictly speaking, guidance, is contained within that document. But at the same time, or rather more in recent years, we've tried to approach fire safety in 3 different ways. We have the general approach, which is where we use the guidance in things like the approved document B. Where that can be restrictive, we now have what we call an advanced approach, which is using a British Standard 9999, which enables us to vary things such as travel distance by having increased fire engineering, such as smoke detection or even sprinklers. And we have the full fire safety engineering approach, which is very sophisticated, using British Standard 7974, which is very much about what kind of fire we're going to get in this building, how fast is it going to spread, what's the amount of smoke it's going to produce, and can we actually get people out in time before we get a flashover? That's the building fully involved in fire. Fire safety engineering is a very sophisticated approach and very expensive. And a combination of the general approach and fire safety engineering was actually used, first of all, by myself and other experts in relation to a building here in Northampton, also on the Brackmills Industrial Estate, almost 20 years ago. Well, it was 20 years ago now, when I think about it. And I thought it might be interesting to just go through what happened with that building, because it illustrates so many of the points we're trying to put across. I don't want you to look closely at that, but just to point out, that is the compartmentation guidance in the approved document B. That was in effect from 2006. It wasn't in effect in the previous document on warehouses. And I ought to just point out that currently with storage buildings, that we have to have a 20,000 square metre limit on the maximum compartment size. So there's our set of plans that was submitted to the building inspector and the local fire and rescue service. Fairly straightforward open plan building with offices at the front. Not that large. This is a fairly typical warehouse, just over 11,000 square metres. Still big enough to contain a couple of football pitches, by the way. And so it's interesting to apply the guidance on compartmentalisation. Where do we put our firewalls in these buildings, if we need to put any at all? And I would just point out that back when this was submitted, approved document B had no restriction on compartment sizes of warehouses. And in fact, a lot of people forget this, there is still no restriction on this maximum size of open plan industrial unit that you can build. So there may be rules on compartmentation in warehouses, but not in industrial units, certainly not single story buildings. Of course, the key thing is if you don't want to put a compartment wall in, you must sprinkler the property. Now, not so long ago, we used to have something called local acts. The government, in their wisdom, got rid of local acts, but they were very valuable tools in my opinion. The London Building Act is probably the best example of local acts. And under those local acts, people like Merseyside, people like Royal Berkshire, people like in Leicestershire could enforce rules on storage buildings. And the maximum compartment size under local acts that you could have without a sprinkler system was 7,000 cubic meters. And I've attempted to draw on that diagram there the actual area that would be covered by 7,000 cubic meters in that building. So quite small. So local acts were very powerful pieces of legislation. But we didn't have a local act in Northamptonshire, unfortunately, and we used looked at the approved document B, which at that time only said that multi-storey industrial buildings, no more than 18 metres high, could only be built up to a maximum of 7,000 square metres without sprinklers. And there is 7,000 square metres imposed on that plan. So this building in front of us was exceeding those other standards where sprinklers would have been necessary. And the owner of this building, or rather the developers, were intent on not sprinkler protecting the building. I ought to also mention, and this could be quite useful for people looking at warehouses, is that if you are picking and packing in a warehouse, that could be deemed a factory. So where you have mezzanine floors, be careful, because there could be compartment rules that would apply to you. When we look at fire engineering analysis, which is what eventually happened with this building, we want to look at the type of fire. And I apologise for all the figures on the screen there, but I've tried to simplify as much as I can the fire engineering analysis for this building. So what we look at is the fire, I've used the term fire loading. So we want to know what kind of fuel and what's the potential type of fire that we can in the building. We want to look at the time the building will flash over. That means that the building is fully involved in fire. And most importantly, with any fire, smoke builds from the ceiling and moves downwards. So we need to know what will be the depth of the smoke layer at any particular time. And here we have at the time of flashover. So in the left-hand column, we apply three measurements on fire growth. So we can have certain combustibles all stacked together. How that's arranged and how it's packed can affect the growth of the fire. So it's not just the actual fuel that's important, it's how it can spread a fire. So we've got these various figures that are given in the analysis. And so we've got, a certain amount of fuel can be 1,500 kilowatts per square metre or 200 kilowatts per square metre. Depending on how that is stored, we can get different fire growths. Obviously, if there's more air, such as goods stored on high bay racking, the fire will grow faster than if it was stacked simply on the floor. And these are the important times to flash over. Obviously, they're quite worrying, that one, 5 to 7.5 minutes. And the smoke layer is not very deep at all. Now, these figures I've put onto an end elevation diagram here, just to give you some idea of the type of fire we anticipated getting in that particular building. Emphasise, not a large building. And I feel that that point there, which is about the 6 metre level, is quite interesting to look at. And I say that because if we have an extremely rapid fire, which I have to say may be unusual, the smoke layer will be up here, but that building will flash over in about 5 minutes. That will be before the fire and rescue service get there. Having said that, we need to be sure that we've got means of escape that can get people out within 5 minutes. And there's another discussion to be had there. But at ultra fast fire growth, which is what I would say the mid-range, what would be more reasonable to expect, not perhaps the worst case scenario, it's likely that the smoke layer would be around this limit. So that's over 7 meters above head height. And when we look back a moment just at the time of arrival here, or rather the time to flash over here, I would say that that's probably about the time of arrival of a fire crew. So my concern has always been in these buildings, we may not get the fastest fire spread, but even a slower fire spread may result in encouraging people to enter that building, and then we get the flashover. And that's something that concerns me. And I should emphasize, this fire engineering analysis was given with smoke vents that should have been put into the roof. And smoke vents never went into the roof of that building. So without smoke vents, those figures could be quite different. So that just gives you an idea of the type of fire you may get in these buildings, certainly when attending as a fire officer. Now, the other thing that I think is interesting to look at is fire service access to buildings under the building regulations. And in the document, there is a set of figures for different sizes of buildings. And for those not involved in this aspect of building regulations or firefighting, I just emphasize we try to make sure that we have sufficient access for fire appliances around buildings in all cases when they're submitted for building regulations. So these are the figures in the approved document. So up to 2,000 square meters, we're only required to provide 15% of the perimeter for access for a fire appliance. But those are what we might call smaller buildings, and there's other rules in relation to how far away the appliance must be. But once we get into 2,000 to 8,000, we're starting to get into some decent sized buildings there. And in the document, the building inspector will say, well, you're entitled to 50% access around that building. And I would just point out to everyone not involved in firefighting that a basic and well-established rule is that we need to surround a building on fire. And I would suggest that these figures, giving us for quite a large building, 16,000 square meters is larger than the building I've just shown you on plan drawing. We're only allowed 50% perimeter. I don't think that's acceptable. And I think in the review of this document, we really need to be pushing for changes to that, or the building must be sprinkled. And I think if the building was sprinkled, we could accept the figures that we have at the present time. So that's something I think that certainly needs debating within the fire and rescue service and government. And another important point for firefighter safety, and I do get questions about this from fire and rescue services, is under section 17 of the approved document, access to buildings for firefighting personnel. Most buildings, access will be met by a combination of the normal means of escape and the measures for vehicle access in section 17. Some of those figures I've already given you. Having said that, most large buildings where a fire engineered analysis is given, the fire engineered solution is usually only for means of escape. In fact, I think it's probably always only for means of escape. I've never known a fire engineering analysis consider firefighter access. Therefore, colleagues in the fire service should be aware that if you have a fire engineering approach, consider the safety of firefighters, because that fire engineering will not consider the safety of firefighters. Something I thought I'd just slot in here when we're talking of firefighting, and it's something that I have come across more than once in recent times, is this inlet valve. You can sometimes find one of these valves at large buildings that are actually connected to the sprinkler tank. But it's interesting the numbers of times that people are confused as to what that valve's supposed to do. That valve is for topping up the sprinkler tank and certainly not for taking water out of it. I mentioned there that schools will often have this facility. I think we'll start to see more of this, so that we may be able to have reduced capacity tanks. And it's something, if you're visiting large warehouses and you see a valve such as this, you should ask the question, what is it for? Is it because you've got a reduced capacity tank? The other problem that we've got is really definitions. Is it a warehouse? Is it a retail building or a factory? So we have structures that can serve a multitude of uses. And those uses can change. I also feel that the footprints of our large single-storey buildings, and particularly warehouse and distribution, are getting larger and larger. And that's probably an old photograph now of the Daventry Rail Freight Terminal here in Northamptonshire, where a lot of these areas now are built on. But these are very large footprint buildings, the like of which we'd not previously seen in Northamptonshire. And I mean, they're bigger even now than what we're seeing on that photograph there. And just as a bit of a comparison from my own personal experience, I thought this would be useful to consider. And then the Livingston Allpack building at Watford Gap, just down the road from the rail freight terminal. We had a fire there, actually just shortly after I joined Northamptonshire. That's certainly the largest fire I've ever been to. And up until recently, and I think another speaker has a photograph of another warehouse fire in Northamptonshire, it was the largest fire ever fought by a Northamptonshire Fire and Rescue Service. Interestingly, when we dive back into the records, that was only 16,000 square metres. Since that building fire, the Stobart's building at the Daventry Rail Freight Terminal was constructed of 19,000 square metres. And nobody really batted an eyelid when that building was built. The largest fire in a warehouse that I've been able to find any facts about is the MOD Donington fire in Shropshire, quite a few years ago now. That was 44,000 square metres. There may well be fires that's larger than that, but I've struggled to find any accurate information on warehouse fires any larger than 44,000. However, just as I was leaving the service in Northamptonshire, we had the IKEA warehouse at Thrapston constructed, 55,000 square metres. So it struck me that these buildings are getting ever larger and we're almost not noticing it. And I certainly feel that legislation is not noticing what's happening in these very large open plan warehouses. I must say that the IKEA building at Thrapston is fully sprinkler protected. It has hose reels and it has lots of other safety features. So it's not that that was a problem. It's just that it was interesting to see the overall footprint sizes, how they were rapidly increasing it. And now I know we're into footprints of over 100,000 square metres. But the other thing to bear in mind, ladies and gentlemen, is that single-storey buildings are getting taller. And Traditionally, I believe in our fire safety guidance, we've deemed single-storey buildings to be somewhat lower risk. Now, here's an interesting single-storey building. It's an automated high bay warehouse. It stores paper towels. It actually has an on-site fire team. There's not many of those about now. In the old industrial fire brigades very much are a thing of the past. It's 47 metres high. That is an incredibly large building, an incredibly large risk. Fortunately, this building is sprinkler protected, and there you can see the sprinkler tank at the side of it. But it just brings into thought that these buildings are not the buildings that we thought warehouses were years ago, that there can be to a variety of sizes and arrangements inside. And again, are we really understanding what's happening in this industry as far as legislation is concerned? And I think the answer is no. I've already mentioned this term, ultra-fast fire spread. In fact, on the warehouse I showed you earlier, the fire engineering analysis said we could have an ultra-fast fire spread in that particular building. But a lot of this information and research goes back some years now to experiments down at the Building Research Establishment. And this is a key lesson to be learned. I think if you take nothing else away from this session today, just think of this, is that a flame can spread from the bottom of a 10-metre storage rack to the top in less than 2 minutes. Just think about that, less than 2 minutes. So even if you have smoke detection, that's going to take perhaps a few seconds to activate. It's then going to take some time for people to actually recognise that the fire alarm's gone off and what should we do. By that time, that fire is out of control. So even if you had fire extinguishers or hose reels nearby at the top of a 10-metre storage rack, you are not going to tackle that fire. The only thing you can do is get out of that building and call the fire and rescue service, and the fire and rescue service will use their own risk assessment, but will probably simply stand outside and stop the fire spreading to neighbouring properties. That building basically has gone. And that is the key reason we lose so many warehouses. It's the way we're storing goods. And I'm not saying we shouldn't store goods that way, but what I'm saying is we really have to sprinkler protect that type of risk. I mentioned the fire service will do their dynamic operational risk assessment. I think they might have different terms now. I was talking to somebody recently, so correct me if I'm wrong out there. And we talk about offensive tactics. That's actually getting inside a building and trying to put the fire out, or at least stop it spreading out of the room or compartment of origin. And the trouble is that really with these buildings, we can't adopt offensive tactics because they flash over so quickly. Points I've already made. This is a building down in Milton Keynes. It's a few years ago now, but this fire occurred whilst I was still in Northamptonshire. And you can see quite a large building, it was the old carriage works storing white goods. That building flashed over in less than 2 minutes. So it was impossible for the fire service to adopt offensive tactics because there's no way they could get in that building safely. So they adopt defensive tactics. And of course, the increasing concern is that perhaps all this water that's going onto the fire is going to mix with the smoke and the pollutants, and it will drain into the local watercourse. So really, we're possibly creating more problems by trying to put that fire out. And I detect that in many cases, fire and rescue services are allowing these buildings to simply burn. And I question, is that the right thing to do? I think these buildings should be sprinkler protected, then we wouldn't have this concern and worry. I've just put up, and that's something if anybody is looking at self-storage units. Self-storage units under the building regulations are deemed the same as a shop and commercial in the purpose group, and therefore the maximum compartment size for a self-storage building is only 2,000 square meters. I think that message is not getting through. I see a lot of buildings built much larger than 2,000 square meters, but without sprinklers. They should have sprinklers, in my opinion. And again, we look at the issue of risk, and we tend to think that certain things are low risk. We traditionally might have thought that a vegetable packing building would be a low risk, but as the history shows us, that's not always the case. And sadly, we've even lost firefighters in such a building as that one at Atherstone in Warwickshire. So the labels we give buildings can be misleading, and we really need to look carefully at what the building is storing and how it's being used, and can a fire spread through these buildings. In this case, there were issues of sandwich panels, albeit I understand they were non-combustible panels, but the panels still fell down in that building. Car parks. I think I shouldn't do a presentation on storage buildings without mentioning car parks, and some will remember the Echo Arena fire in Liverpool back in 2017, where we had the car park well alight, and which shouldn't have come as a surprise to many of us in the fire service, but it might come as a surprise to people to know that our building regulations guidance in relation to car parks is written on the principle that fires don't spread from one car to another. Well, ladies and gentlemen, they certainly spread, not only to every car in the car park, but here you can see some incredible photographs where the concrete has spoiled and it's gone through the floor, the actual concrete floor of that car park. I would point out that the approved document B is hopelessly out of date when it comes to car parks. And anybody involved in approving building projects needs to consider a lot of the evidence on car parks very carefully. The other issue with modern industrial or storage buildings is they're constructed speculatively without any knowledge of what they will eventually be used for. And in fact, the building I showed you right at the beginning was a speculative building. So we had really lines on a drawing, and we had no idea what the contents were going to be, what the risk would therefore be when it was occupied. As I've said, they can be used variously for warehouses, factories, retail premises, and for mixtures of those uses. And that has an effect on how they are protected and how they should be managed in relation to the fire safety. And many buildings will change their use several times during their life. The question is, will we always be able to address the change in risk when those buildings change their use? Some buildings, as we've already got examples of, are only used seasonally, such as vegetable packing warehouses. And many warehouses are owned, managed and operated by different parties. So all these things tend to complicate the management process of buildings. And I think these are areas we need to address to make sure that we're not losing so many to serious fires. To recap, in some ways, I think we have changing hazards and risks. The sheer size and volume of buildings is increasing. Travel distances in excess of what was previously considered normal is often something to be addressed. And for those that, who are not in the world of building control and fire and rescue services, travel distances is simply the distance people have to travel from the furthest point in a building to a place of safety. We used to have very simple rules on that. Those rules are being challenged because we're building ever larger and larger buildings and buildings with much larger footprints. So the travel distances are becoming much larger than they used to be. And the other thing, and something perhaps for our colleagues in the fire service to bear in mind, is if travel distances are exceeding, then the access problems are also increasing for firefighters. Bear in mind that if people have to travel out of a building from a certain part, then it may be that the firefighters got to go in. And so those figures are linked, and I often don't think we appreciate that enough. So we've got ultra-fast fire spread leading to early flashover, either before or after the fire brigades arrive. So the speed with which fires can spread in these buildings is having an effect on the safety of firefighters. And for anyone that's served in the fire service, it's nice to see the buildings flashed over before you get there. You don't want it happening after arrival. We've got new hazards and risks. We've got corresponding new risks and hazards, I suppose, and liabilities for people like fire services in relation to pollution of waterways. Is it possible that a fire and rescue service could be prosecuted for putting a fire out and perhaps putting pollutants into the watercourse? I think that's perfectly possible. I've already mentioned the environmental concerns. A lot of concern, understandably and rightly so, about the environment. And that's an area that politicians would like to address. The best way of doing that is with a sprinkler system, in my opinion. That will certainly stop pollution of the environment by unwanted fires. And on that topic, there's much evidence already available of the damage that can cause in pollution of rivers, waterways, and our own water systems. And perhaps that's a lecture for another day. But where we have a sprinkler system in large single-story buildings, the water consumption is much smaller than it would be for the fire service. And there's various tests and trials being done elsewhere, even on such a high-risk building as rubber tire. There's a spelling mistake there, I've just noticed. That sprinklers do a fantastic job on ensuring that fires don't spread and therefore cannot create a pollution problem. So problems for resolution. We've got composite buildings, storage and retail is often in the same structure with no fire separation. We've got significant fuel loads. When does storage become industrial? We've got the issue of changes of use. We've got the problems of speculative buildings. We've got the problems of occupiers, often detached from the owner, and the several people in the chain of who actually owns the building and who's running that building. Modern supply chain management requires extreme flexibility of layout. So more and more we are seeing open plan. There is no way that these developments will have a compartment firewall to stop fires from spreading. That is just not acceptable in this modern world of distribution. We've got modern methods of building construction, light structures, sandwich panel insulation. Again, another topic for further discussion. Yes, we've got changing attitudes post-Grenfell, but one of the worrying things for me is that following Grenfell and reports such as Dame Judith Hackett's report on building a safer future, that's really only focusing on residential buildings over 10 floors high. Yes, cladding they seek to address, but cladding applies to lots of other buildings too. They report correctly highlights cultural change is needed across the whole of the building sector. And I think that's certainly true in the area we're discussing today. Yes, I've too have seen a race to the bottom with these designs. And there's an important issue on competency, both in the construction and the fire safety sector. And we need robust and transparent testing regimes. Again, this is probably more related to the cladding issue, but we need to be careful of all these areas, even in relation to single-story warehouses and industrial buildings. For further guidance, there are two documents that you could look at. I was involved in the production of both of them. Both getting a bit old, And that's something else that I feel with the changes of legislation, the new fire safety bill that's about to take place. We've addressed issues about building regulations guidance, but we're not really addressing issues of guidance to operators and fire and rescue service persons and others once the building is built. These documents are about dealing with risks once the building is constructed and occupied. And they're getting a bit out of date now, and that really needs to be looked at. And with that, I will close and ask for any questions. Thank you very much.
Thank you, Ian. I'm very pleased to note that over 260 individuals have been listening to your comprehensive presentation. And thank you for the questions received so far. Please keep them coming. Our speakers will respond directly to some of them as we go, but we will reserve others for our panel at the end. And now I am delighted to welcome Ian Cox, the Chair of the Business Sprinkler Alliance, who will join Tom Roach, Secretary of the Business Sprinkler Alliance, for the next presentation. Over to you, Ian and Tom.
Hello, my name's Ian Cox. I'm the Chair of the Business Sprinkler Alliance. And today we're going to talk to you about some issues around warehousing. To begin with, who is or what is the Business Sprinkler Alliance? We were established in 2010, and as you can see on the screen, BAFSA, of course, who else? The National Fire Chiefs Council, the European Fire Sprinkler Network, FM Global, the Fire Protection Association, and the National Fire Sprinkler Network. And that's why we call it an alliance. Everybody joins together to see if we can ensure that businesses benefit from sprinklers in the way that the domestic sprinklers are being pushed by the fire service, etc. We felt there was a gap there, and hence the alliance. What we're trying to do today, however, is we'd like to look at warehouses and the regulations surrounding them. More particularly, we'd like to tease out what a warehouse is or isn't. We'll cover the basics on sprinklers. I think some more technical presentations will be done at other times, but we'll also cover the benefits of sprinklers, which, especially in business and commercial settings, we feel aren't fully realised or recognised. The issue here is what is a warehouse. On the left, you'll see what you might regard as a traditional warehouse, where it used to be something with 3 men, and there were men in those days, with 1 forklift. Stuff came in, may got broken, the bulk may be broken, but basically stuff went in, stuff came out as a warehouse. On the right, what you're seeing is what it looks like more like today. You walk in and you're faced with an array of floors and levels and stacks and racks. It's completely different to what the regulators may have had in mind when they designed the regulations. And you can see that nowadays you can not only get the stacks and racks together, but you have the auto picking as well. So you have humans, you have computers and automated machines, and you have huge internal volumes. So warehouses aren't really what they were when they started to design the regulations. And you can see that up to 1,000 workers were evacuated in the Amazon fulfillment center, I believe they call it, in a warehouse. But up to 3,000 people can work in these places. So, from 3 people in a forklift truck, we're up to 3,000 people. It's different. The other thing that's different is demand. If you use the internet for shopping at all, and I'm sure that's most of us, you'll know that it's changed completely. I think BT ran a thing to see how long people would wait for the phone to ring before they hung up, to see what patience levels were like in the population. It's got down to something like 15 seconds now. Now, people are expecting stuff to be delivered the day after they've ordered it, if not the same day. And we can see that the e-commerce is growing. What people fail to realize when they order something over the internet or the phone, or the mobile or what have you, is that you actually need physical constructs to help deliver this. I've heard it called clicks and mortar. Clicks are fine, but without the actual physical infrastructure, the stuff won't reach your doorstep. So we now know that we are using logistics in a different way, and warehousing and places like we've seen the e-commerce rely on these warehouses to deliver an efficient logistic network. But consumer expectations are driving this. Following the ASOS fire some years ago, somebody tweeted in within hours of the fire happening, "There go my prom shoes." They'd expected to order them on the Friday morning and wear them Friday night. ASOS were only off the run for 48 hours, but people still felt that this was a failure. And people looking at this, when they see this, they think, oh, that's it, they'll go elsewhere. So the market's disrupted. People often think that these fires are rare. And when you look at these two here, they're devastating when they happen, and they often appear in the news. They generate headlines because of the size of the fires, because of the size of the buildings. And as a colleague said, you only have to see how big it is when you see the aerial shot, and the aerial ladder appliance that's trying to pour water on the fire is a tiny little thing looking like a dinky toy next to it, and the water doesn't even reach the middle of the building. But they are far more prevalent than you might think. 43 fires per month in England, Scotland and Wales. 43 a month. That isn't rare. Now, they range in size and they're not all total burnouts, but it's more prevalent and more devastating than you might think. So that's giving you a little overview of what we might think we mean by warehouses. The point I'd like to make before I hand over to Tom to take you through the next section is actually a warehouse is completely different to what the regulations were designed to cover. And I think Tom will take you through some of those issues now. Thank you.
So thanks, Ian. I'm going to take you through the next section, which really looks at regulatory guidance. And one of the first things to sort of talk about here is the fact that actually we have sort of devolved powers. So regulations are slightly different between England, Wales, Northern Ireland and Scotland. Their basis is the same. Regulations around buildings and how they're constructed have a life safety focus. In terms of things like warehouses, it's what is the building used for that determines how big a compartment you can perhaps build and the height that building could be. We're more used to seeing this guidance in the form of certain documents. In England, approved document B. It's no surprise that Wales has similarly approved document B. In Northern Ireland, it's technical booklet E, and it's the technical handbooks from building standards in Scotland. And these talk to those elements that you need to sort of, or the guidance for the building of structures like warehouses. So what do they really say? And I think one of the key things when we think about warehousing, think about what Ian said, is like how big a volume or how big a compartment could you build before you run into a requirement to either subdivide or put in some form of suppression like sprinklers. Most people are surprised that when we talk about England and Wales, that number for the warehouse compartment that you can build of a single story building is 2,000 or 20,000 square meters, or to a height of 18 meters. Go north of the border to Scotland, they take an approach where they use, they sort of take building use into storage building class 1 or storage building class 2. So storage class 1 really is sort of flammable liquids type special hazard storage, and that's at 1,000 square meters as a compartment size. So you'd have to have a wall around that or an enclosure around that. Where it comes to sort of more general warehousing, it's 14,000 square meters. Now those numbers for a lot of people are not so tangible. So what I'd say to you all is just close your eyes and imagine your local Wix or home-based store. Other DIY stores are available, but just close your eyes and imagine those stores. On average, you're talking about these compartments we're talking about for warehouses can be 6 to 8 times the size of your average Wix to home-based store. Truly colossal sized buildings before you run into a guidance or piece of guidance that says they should be subdivided or provided with suppression. What does that really mean? That means there's quite a lot of stock that can be stored in such a building. And if there is a fire, it's going to be quite a large event. People then ask about our regulations and sort of try and compare them to other countries, you'll notice on this screen, I haven't mentioned Northern Ireland, there is no limit in technical booklet E for warehouse compartment sizes in Northern Ireland. If we look at our nearest neighbours and ask, how do they approach this, we shouldn't be surprised to see that actually it's much smaller compartment sizes. Generally across Europe, for a warehouse, you're looking at compartment sizes approaching about 5,000 square meters. So typically, 3 times to 4 times is what we're allowing here in the UK to what's in Europe. Why is there a difference? Our approach is on about people being able to escape the building. In Europe, the focus is also on that, but at the same time, can the fire be controlled by the fire service, and could they affect rescue? And their belief is it's much smaller compartment sizes is how to do it. From my perspective, fire's fire. If it's a big compartment full of storage, particularly at 14,000 or 20,000 square meters, the chances of the fire service stopping that fire once it takes hold without being subcompartmented or with suppression like sprinklers is very, very difficult to achieve. So one thing that's in that mix, and something that I've personally looked at along with other members of the BSA, is that understanding of building regulations. We talk a lot about them, we talk about guidance, but do people really understand them? And it shouldn't be a surprise that most business owners believe if they follow the building regulations, their property will be protected, when actually the outcome delivered by the regulations is their people will be safe, their building may be destroyed. That's okay as a regulatory outcome. If you want a different outcome, or you want to protect the building, you have to do something else. That's an element that's missed when we talk about regulations. So I've spoken about suppression and sprinklers. One of the things I'm very clear about is not everybody understands how they work. I'm fortunate, I have access to sort of, sprinklers, so I'm used to sort of handling them. If we talk about them, the thing you'll notice very obviously is a red element in them, a bulb. And if you look closely at them, you'll be able to see a plug. And that is in place to hold back the water. And that's what stops water flying out of a sprinkler until something happens. And that something happening is a fire. And in a fire event, what happens is that sprinkler starts to heat up. And most importantly, it's that thermal element, which is a glass bulb filled with a temperature sensitive liquid. And as a fire ensues, that bulb heats up. It gets to a point where it breaks. Now, that sets off a chain of events, which is quite simple. If that's the only thing, that bulb is the only thing that's holding that plug in place, next thing that happens is the plug is ejected, now comes the water. So water is then projected onto the fire. It's as simple as that. If you look at those diagrams, there are no wires. It's not smoke, it is heat. You have to generate enough heat to expand that fluid in the thermal element to break the bulb to allow the water to flow. So if we take that a step forward, how do we know how much water to throw on a fire? Well, that's really the science bit. So if I imagine a fire in a building and I could plot some sort of characteristics of that fire and say up the y-axis is the heat release rate from that fire over time, in a fire situation, we would see that heat release rate rise over time in a fire. Depending on what's actually being burnt and some of the conditions of the enclosure that it's in, it could rise really quickly or more slowly. But in terms of suppression and sprinkler systems, there's a point at which we could apply water. And if we apply water to that heat release rate, the growth of the fire, we can do one of two things. We could enable the fire to be controlled. We're putting enough water on it to knock the fire down, stem that heat release rate, or we're putting water onto the fire, but it's having no impact. The fire continues to grow. If we put enough water onto a fire, we can achieve suppression. So that's the theory. If I want to sort of show you one that I did earlier, here's a video from a fire at our research campus. I work for a company called FM Global. This is our research campus in the US. This is a fire involving lithium-ion battery pouches in cardboard cartons. It's about 4.5 meters high, and the ceiling's at about 9 meters. You've got a view. We're just coming up to a minute into the fire since ignition. You can see the fire's already out of the top of the storage array. The view in the top right, you're looking backwards over the array. And on the left is that heat release curve measured at the ceiling. And you can see how over time it's rapidly going up and nothing is stopping it. This fire is going to continue. It's having a slight wobble, but actually it's going to start to take off again. And you'll see that heat release rate grow. Now, at some point, like now, we start to sort of think about, let's deploy a sprinkler, i.e. that bulb has got hot enough, it's broken, out comes the water. We'll start to deploy water into the fire. You'll notice in the graphic that that curve starts to come down, the heat release is going down, the fire is starting to be suppressed. And over time, you'll notice that curve is continuing to come down. You'll see a lot of steam, a little bit of light smoke, but the water's having that impact of containing that fire. And if you think about this in a larger warehouse, at about minute 2, we're starting to contain the fire. At minute 2, we've probably called the fire service in real life, and they're just about starting to sort of get ready to sort of get in their trucks and come to this location to deal with that fire, where the sprinklers have already taken a huge step to suppressing that fire. So hopefully you can see how that science delivers into reality and why people see sprinklers as a very effective device for controlling fires in warehouses.
Can we unpick now the economics of warehouse fires? In the BSA, we've done some research into warehouse fires, and it's quite telling what people think happens and what actually happens, as is often the case, is different. So we looked at the things like the lifetime costs and how much you can install in warehouses by fitting sprinklers, and it's quite large. Large warehouse fires without fire sprinklers, the cost is just under 4 million. For a large warehouse fire with sprinklers, the cost over a lifetime would be just under 1 million, 862,000 and something. You've got to add in the cost of installing sprinklers, the prevalence of fires, etc., even the cost of unemployment, fatalities, etc. What it shows, when you boil it down, is that there is a cost benefit to sprinklering warehouses above 2,000 square meters, and the cost benefit is even greater in warehouses above 10,000 square meters. And if you remember Tom's slide showing 20,000 limit in the UK as opposed to Europe, we believe this evidence is fairly telling of the benefits of sprinklers. It's a busy slide, and you may want to look at it in more detail when you get a presentation sent to you after the webinar. We also did some research into the environmental effects, because it doesn't just affect the business, it affects everybody around it. Indeed, the congestion because of the fire and the damage after a fire can affect industrial premises all around the building that actually burns. But the fire you can just see in the background there is from Manchester in February of this year. And residents were told to stay indoors and shut their windows because of the smoke. And you don't really know what's in the smoke. It's not good for you. Even if it isn't purely toxic, it's definitely bad for you. Of course, people are told to stay indoors and shut their windows, so they rush out and video it on their mobiles. But you look at the amount of CO2 that's needlessly emitted from industrial and commercial building fires in a year. It's quite significant, and it may not be, it may not be up to the level of a Chinese coal burning station, but it will actually add to our carbon footprint significantly. So when we look at it across the board, the environmental impact, loss of lives, the injuries, the detriment to the UK PLC, the local impact on businesses and people's lives, etc. When you add it all up, we think it's about 3.4 million cost to the UK every day because some commercial industrial buildings aren't sprinklered. Now that, you know, in the Treasury scheme of things, 3.4 million isn't much, but if you can save the money, why shouldn't we? Because the other aspect that people overlook is the impact on the business itself, because some don't recover. The ones that do recover lose opportunity. And that's something I'd like to touch on now, and this is an example of this. This is a tale of two fires, both in last year in 2020. On the left is a fire in Kent Foods in Basildon. It's about 7,000 square meters. On the right, Blakemore holdings in Hastings, roughly the same size. You can see the difference. The picture tells the story. But the one on the left, they may be back operational in 15 to 18 months. The one on the right, they lost a day just tidying up after the sprinkler actuation. That's, if you like, visual evidence of what we've been saying all along. Sprinklers are very, very effective. And the National Fire Sprinkler Network, with what was then CFOA, which is now the National Fire Chiefs Council, back in April 2017, undertook a study of the efficiency and effectiveness of sprinklers. Now, a couple of things, you can see the outcomes there, but you should remember a few things about this. It's across all types of buildings, but primarily these are real fires. These are fires that the fire service attended. So this isn't an experiment or a desktop study. This is real life evidence, a bit like the real life evidence on vaccines as opposed to the trials. This is real life. And this is based on the Fire and Rescue Services definition of success, not just a figure that we might have pulled out of the air. So these are the benefits from the data from the Fire and Rescue Service. And as you can see, 94% operational reliability, 99% effectiveness. Vast majority involve 5 sprinklers or less, and indeed the majority involve 1 sprinkler only. Sprinklers are far more effective than people realise, and one of our roles in the BSA is to dispel all the myths about, oh, they all go off at once, etc. We blame Hollywood and Tom Cruise and others for this, but it's actually in the hindbrain of a lot of people, including, I would say, architects, that the water will suddenly burst out of them and destroy their lovely building. Actually, their lovely building is a better chance of staying in one piece if you fit sprinklers. So that's my input. I'm going to hand over to Tom now to summarise. Thank you for your time, and I believe we'll be doing a Q&A session later.
So thank you, Ian. So just in summary, I think that the key points we want to make, covered a lot of ground in this session, is really sort of key takeaways for us as the BSA that we'd like to sort of make sure you sort of walk away with, is that you've seen some of the science, you've seen some of the evidence for why we think they're effective and reliable. And that's our key message. Sprinklers are very effective and reliable, particularly against fires in warehouse situations. Secondly, the guidance is really aimed at sort of very large buildings, which are beyond the capability of the fire service to sort of control and sort of intervene, really, without the aid of some sort of subdivision or active fire suppression in the form of sprinklers. And that's all wrapped up in the fact that if we start looking very carefully at the economics stack up that say sprinklers will have a benefit in terms of reduction in damage, reduction in sort of emissions from the fire, and at the same time casualties over time, such that for warehouses larger than 2,000 square meters, there is a case that they should be included in our regulatory guidance. So they're the 3 points we'd like to leave you with. Look forward to some of your questions along with Ian on this session. Thank you very much.
Many thanks, Ian and Tom. Our expectations from online suppliers really have become quite extraordinary, and I doubt whether an average online shopper gives any thought to the pressures on the providers or the increased risks, fire or otherwise. And now I'd like to hand over to Alan Crichton, BAFSA's design course facilitator and chairman of the technical committee. who will provide technical insight into the challenges of designing sprinkler systems for warehouses. Over to you, Alan.
Hi, my name's Alan Crichton, Technical Chairman of BAFSA. I'm going to talk today about sprinkler protection to warehouses. So warehouses, modern warehouses have got far larger and more complicated, and I don't see that changing anytime soon. They're not just places to store goods, now they're a hive of activity. Lots of people work in them. The fire protection of warehouses is becoming more complicated, and we have learned over a lot of devastating fires through years in history and applied robust fire protection practices such as compartmentation and sprinklers. Okay, so I'm going to take you back to Cheapside Street in Glasgow. The Cheapside Street in Glasgow is a whisky bond in the centre of Glasgow. And if anybody knows, this part of Glasgow where it was down next to the Clyde. It's now the financial district. So there was lots of warehouses down that area. Okay. The warehouse was owned by Arbuckle Smith and Company, and it held approximately 21,000 wooden barrels of whisky and 30,000 gallons of rum. And at the time, there were no requirements for sprinkler protection. Okay. On the evening of 28th of March 1960, a fire started in the warehouse. The first crews arrived 6 minutes after 999 was called, so they arrived at 7:21. Okay. And then, whilst they were on site at 7:49, 8 tenders were on site, and this was increased to 22 tenders by 8:12. So there was 450 firefighters in attendance. Okay. There was an explosion that blew off the front and the rear walls, causing collapse. Quite a famous fire, actually. Okay, so the fire actually took a week to extinguish. Unfortunately, the fire wasn't without casualties, so there was 14 firemen and 6 salvage corps members lost their lives during the blaze. The incident remains Britain's worst peacetime fire service disaster. The fire was overshadowed by one in James Watt Street in Glasgow, which was formerly Whisky Bond, converted to a factory, and 22 people died. Now, the important thing here is that because it was a Whisky Bond, all the windows had bars in them, and they never took the bars off. So one of the reasons why people died was that they were trapped and they couldn't get out the windows, and that's a change of use. So this is basically one of the things that became prevalent over the years, is that when a warehouse has changed the use, you have to modify the fire procedures, etc., and to cope with the change of use, and that's what didn't happen at James Watt Street. Okay, back then, Glasgow's reputation for tragic fires after the Second World War resulted in poor building standards, and there was many hadn't been modified from the original purpose. Okay, so many of the industrial premises in that area were still 19th century, and because Glasgow was fortunate not to get bombed during the war, we still used the existing buildings, and we had lots of fires because of that. So these buildings had to be updated and modified to the new building regs. So that was the start of getting the building regs up to speed because of the fires in that period. But if we fast forward a few years, we had the Gardman fire. So the Gardman fire was a factory, which I think it was garden furniture. And it was a factory of 38,000 square metres, and it had no sprinklers, which surprised me when I read it, because anything over 20,000 should have sprinkler systems in it. So the fire occurred on the 11th of March 2018, and it destroyed the building. Okay, so once a factory fire has begun to spread, it may become too dangerous for firefighters to commit to the building. And more than likely, the building will be lost. In most cases, the company will either be shut down or sold with a loss of revenue and jobs. So sprinkler systems not only protect life, they protect their businesses. Okay. I know it's been touched on already, but 4 areas of the UK have got different building standards when it comes to installing sprinkler systems. In Scotland, Class 1, Class 2 warehousing, it's up 14,000 and more square metres and more has to have sprinklers installed. And Class 1, such as whisky warehouses, anything over 1,000 square metres up to a maximum of 2,000 has to have sprinklers installed. In Northern Ireland, any warehousing under 18 metres is 20,000 square metres, otherwise it has to be sprinkled. And if it's over 18 metres in height, it's 4,000 square metres, it has to be sprinkled. In England and Wales, anything over 20,000 square metres has to have sprinklers installed. Okay. Still falls quite short, the sprinkler protection in line with Europe. Okay, so we're going to the design part of it. So when you're designing a sprinkler system in a warehouse, you need to know the following information. You need to know what you're storing. You need to know how you're storing it. If you're storing plastic, what the percentage of plastic is in the goods. What type of packaging do the goods have? What sprinkler regulations, what standards are you going to be installing to? Okay, so the information will determine the density and arrangement of the sprinkler system. So we'll talk about standards, installation standards. When it comes to warehousing, there are specific standards that have to be followed. Where the warehouse is built, who owns the warehouse, who are the insurers of the building, you need to know that. And that would all depend on what they're going to install it to. So in America, we've got NFPA and FM standards. NFPA, the national standards, and FM are by the Factory Mutual Insurance Company. Okay, both standards are driven through live fire tests. So they set stuff on fire and they put it out with sprinklers and they learn through that. Okay. And American standards are generally limited to buildings up to 15 metres in height. As in America, the land's cheaper, so they tend to have larger footprints because they're buying more land. Okay. So warehouses in America are quite a big area they cover. So in the United Kingdom, we can still use NFPA FM depending on the insurance company and dependent on the people who own the company. Okay. And as the land in the UK is more expensive, warehouse tends to have a smaller footprint, and therefore we tend to use BSC and 12845. Because we've got a smaller footprint, we tend to build higher. So the warehouses in the UK are much taller than the ones in America. So it's not unusual to have a mixture of standards. Okay, so it's been known to protect the racks by FM or NFPA, and then protect the roof by BSC and 12845. But that needs to be approved by the insurance company, the building control, etc., etc. All the stakeholders, the client, probably the most important thing. So what you've typically got in a warehouse is freestanding block storage where you're piling stuff on top of each other, and then you've got palletized racking where you need a forklift to get it out. Okay. So freestanding block tends to be located in the goods in, goods out before they're moved onto the palletized racking or moved into the trucks for dispatch. And the beam pallet racking is where it's put for storage to be moved later on. Now you can store higher then. So moving on to new type warehouses, what you tend to get in some new warehouses is mezzanine pick bays, where you've got shorter racks, they're made of wood, and you've got a whole load of smaller boxes in there. You've actually got people getting in there to pick out what they need. Hence the name pick bays. Okay. And they tend to be in multi-storey mezzanine floors, and they can be 3 or 4 stories high. So it's basically another building inside the building. So they need to be protected. Okay. And a lot of them are in plastic tubs that are hard to protect also. And they do require complicated sprinkler designs. Well, in some cases, there are also robots who will also operate on these floors. Okay. If we move forward again, the likelihood is that there's going to be more robots and more automated picking in the warehouses, which again makes it difficult to, which again is going to make it difficult to sprinkler protect. Okay, so robots will increase fire risk to the building, and that must be considered when classifying the sprinkler installation or system. Modern warehouses also tend to be busy places. In some instances, up to 2,000, possibly more, employees. So they're not becoming more warehouses now, they're becoming more kind of factories as such. So again, it could be classed something different. So that's all something that's being looked at. So what I'm going to do, we're going to base a system like so, where you've got palletized racking on one side, and you get freestand goods in and goods out. And we're going to base it in the EN 12845. Okay. So for instance, what we've got here is freestanding goods. So when you get freestanding goods, the distance between your sprinkler head and the top of the goods has to be a minimum of 1 metre and a maximum of 4 metres. If it's over 4 metres, you then need to increase the density. And the height of the goods here will determine what the density is. Okay, and we're just going to talk about the density shortly. So just a little instance here where we've got palletized racking, and somebody's decided to store right up to the sprinkler head. So in this area here, you should have a minimum of 1 metre between that head and the top of the storage. Okay, so that's basically housekeeping and management of your storage. It's only the client that can determine that. And then when you've got roof sprinklers, which are more than 4 metres from the top of the allowable storage, you need to add density. So for instance, if that's the height of your actual stored goods, and when you work out what your density is, your base density, you might be able to list out, you might be able to store to that, and that's what we call allowable storage height. Okay. 4 metres from that, you should have sprinkler protection. However, in this case, we've actually got a little bit more. So for instance, that first metre above the 4 metres, you would have to add another 2.5 millimetres of density. And then above that, whatever that meterage is, if it's 5 metres, you would add 5 millimetres of density. So it's 1 millimetre of density per metre after that. That's very basic. Your sprinkler contractor will be able to tell you exactly what you need, or consultant. So when you've got stored goods such as this, so basically piled on top of each other, what you're going to get is surface fires, because there's not a lot of space between the goods themselves for the fire to spread. So what you might get is something like this. You'll have a fire here. That's the fire in your goods, surface fire. Your sprinklers will operate, and then your water will come out. And then what we get is water on the floor. So the depth of the water on the floor is called the density. So that's measured in millimetres. So every millimetre you will get, every minute you will get an amount of water. So it could be 5 millimetres per minute, 10 millimetres per minute, 15, 20 millimetres per minute. I've done one up to 35.5 millimetres per minute. So that's, if you can picture it this way, over an area, a design area, you would have over a foot of water in 1 minute. Okay. Now, if you think about it, warehouse sprinklers are set to run for 90 minutes. So 35 millimetres a minute could be up to 1 million litres of water over the period of 90 minutes, discharged over that floor area. So it's quite a lot of water. It's just, hopefully you can understand the amount of water required in warehouse design. So when determining category of storage of goods, you need to know what you're storing, how you're storing it. Okay, so for instance, on the left-hand side, we've got washing machines stored on top of each other. But we've got the washing machines, okay, which are basically metal. So there's a light fire risk. You can't really catch fire. However, what we do have is expanded plastic foam around it, polystyrene, wrapped in plastic. Okay, now that is quite a high fire risk, right? So in an instance like this where you do have a fire, what's going to happen? What's going to catch fire is the plastic foam and the plastic wrapping. And if you think about it, that plastic wrapping and foam will burn away quickly. Okay, and the structure itself, when it burns away quickly, the structure itself will lose its rigidity. And what could then happen is that could collapse. And then when it collapses, it's spreading the fire all over the factory floor and causing fires all over the place. And that could overpower or overwhelm the sprinkler system. Okay. So in instances like that, I think that one's stored too high. It should only be 3 high and not 6. The sprinkler system's only set to a certain density to cope with that. Again, when you get block storage, you've got to keep it in areas. So the maximum area of a block storage is 150 square metres. And then when you've got 150 square metres block, you then need to have 2.4 metres around each block. And that's to create a fire break so that the fire doesn't spread from one block to the other. So that's block storage. Now moving on to palletised racking. 2 ways of protecting palletised racking. You can protect it from the roof only. So from the roof only on the left-hand side, you can see where the fire goes. There's space around it to grow. So you can't store too high, then you get a high density of water at the roof. Now, the other option here is to put sprinklers inside the racks. It's called in-rack sprinklers. Okay. And when you've got in-rack sprinklers, you don't need as much density in the roof because the fire's also being contained within the racks itself. Okay. So for instance, you might need 35.5 millimetres at the minute on the left-hand side, and on the right-hand side, you might only need, all in all, about 15. It's a lot less water on the floor, a lot less water damage, a lot smaller diameter tank, pumps, pipework, etc., etc. Okay, but there is regulations to in-rack protection. So when you've got in-rack protection, the head's based in the middle of the racks. So in the middle of the racks, we call the flue. So that's the longitudinal flue, which runs the full length of the rack. That has to be kept at a minimum of 150. And that allows the water to flow down and through and in and make sure that we're catching all the areas of potential fire spread. Okay. But not only that, we also need a minimum level of 150 millimetres from the deflector to the top of the storage, which is stored inside the rack itself. Okay. And if we look at it the other way, what we basically get is each pallet is put in, and we need to put a head spaced at the gap between each pallet. And each pallet is called, we need 75 millimetres. Now that's what we call the transverse flow. So we need a head down the longitudinal and the head spaced at each transverse flow. Okay. When you get to the top of the racks, again, we protect the top level of the rack. So the A dimension is the actual stored height of the goods. The B dimension is the allowable storage height, depending on the density of the roof. And the C dimension is 4 metres maximum. Now, in this instance, you shouldn't be adding more density at the roof. What you should be doing, you should put another row of heads at the top level of the racks, above the top level of the storage. And that's only if your C dimension is more than 4 metres. Okay. So again, head positions in racks. So you can see here what we'll have. You can either have pallets in the UK or Euro pallets. The Euro pallets are slimmer, which means you can fit more pallets inside a bay. Now, typical UK pallets will fit 3 pallets in a bay. So when you've got that situation, the white dots here will show you roughly where the sprinkler heads will be. And that will be dependent on the risk of the goods. It might be at every level, or it might be at every other level. It'll certainly be all the way down the racks in every single transverse flow. So you can get quite a lot of heads in racks. Euro pallets, you would have 5 heads. So if you think about it, 4 heads for UK pallets, 5 heads for Euro pallets. Okay, so it's in every transverse flow. So the management of the storage is vastly important on this. When look to hydraulically calculate systems, because pipe work is hydraulically calculated, it's not pre-calculated, so we have to actually work it out. When you're working out the amount of heads operating in the racks, it's 3 levels of pipe work in a rack. Now, if the aisle between the racks is over 2.4, which gives you that fire break, that's the same as we've got in block storage, you only need to calculate on 1 rack. So that'll be 3 heads and 3 levels, 9 heads operating. Okay. When you've got aisle widths 1.2 to 2.4, what we're basically saying is that we're going to protect 2 racks in operation. So that would be 3 heads and 3 levels over 2 racks, which would be 18 heads in operation. And then when you're less than 1.2, we're protecting 3 racks in operation at 3 levels, so it would be 27. Okay, 27 heads in operation. Right. Now we talked about flow spaces. So as you can see here, the flow space down the rack, okay, has to be clear for sprinklers. It needs to be 150. And we've not got that here. So that wouldn't be very good. It means if there was a fire, we'd struggle to get the water to the base of the fire. Okay, then it wouldn't be, the water would be unable to spread and not control it. And that could potentially lead to loss of the building. So it's very important to keep your housekeeping up and make sure things are stored properly and allow the sprinkler system to operate. Another thing, when we talked about the aisles, the main reason having the aisles is so that forklifts can get down there, but if it's over 2.4 metres wide, we need that 2.4 so the fire doesn't spread from one rack to another. So when you get a situation like this where we're just storing stuff down the middle of the aisles, if we're only calculating it in one rack in operation, that fire is going to quickly spread from one rack to the other through the goods stored between them. So that's going to overwhelm your sprinkler system again. So again, it's all about housekeeping. So once the system's installed, we need to make sure that the housekeeping's kept up to date, etc., etc. Another big issue is idle pallet storage. Okay, now, basically idle pallet storage is a huge risk. So we need to make sure that we control the amount of pallets being stored and how they're being stored. So what the rules say is basically wooden pallets, we can store them in high hazard warehouse systems, which are called high hazard. 2x2 pallets, so 4 pallets in plan, up to 1.6 metres high. That's it. Okay. When you get plastic pallet, it's 1 pallet up to 1 metre high. Okay. It is best, where possible, to store the pallets outside 10 metres away from the building. Otherwise, you actually probably need to increase the density at your roof to 25 millimetres a minute as a minimum. Okay. Now I'm going to come away from standard roof protection because there's another way of doing it. ESFR sprinklers. Okay, so ESFR sprinklers is early suppression fast response. So these sprinklers are designed, they were first developed by FM to facilitate high pile storage 7.6 metres in height without the need for intermediate sprinklers. Okay, so your roof and rack system, which we just ran through, is called control mode technology. So that controls the fire until the fire brigade get there and then they'll extinguish it. Most of the time it'll extinguish it itself, but just in case the fire brigade and they check it out. ESFR is suppression mode technology. Now what that basically does is extinguish the fire. It works different. So suppression mode technology has much less tolerance, okay, for the design. So the building has to be designed along with the sprinklers to make sure that the ESFR systems work properly. If you can't meet them, you shouldn't be using the ESFR. Unlike standard sprinklers, right, ESFR systems are designed. So standard sprinkler systems are designed for a density over an area. ESFR systems are designed for amount of heads working. So ESFR systems are designed based on 12 heads in operation. So the way I like to picture it is you've got 12 hose reels at your roof operating, potentially 820 litres per head. So you could have 9,851 litres per minute. Okay, over 12 heads. So again, 592 metres cube of water on your floor. Now that might be more than that, might be less, depends what heads you pick. Some of these heads operate at 3.5 bar. Okay. So it works different. So it's the number of heads in operation. So if you just imagine 12 hose reels shooting water straight down, and that extinguishes the fire. So some of the limitations are maximum ceiling height of 12.2. Now this is BS EN 12845. It's TV 209. They cannot be used for pick bays. So when you've got these plastic tubs where people go and pick them, you cannot use ESFR systems. The maximum slope of the roof is 9.5 degrees. Limited obstructions below the heads. You need that so that we get cover and nothing's interrupting this jet of water that's coming down. You need to increase the management of the system, so increase maintenance. No automatic smoke venting is allowed. And you're going to have large pipes, pumps and tanks. Okay. So no in-rack sprinklers up to 12.5 metres. But again, as I say, it's very limited to the use of the building. So then we come to water supplies. So what warehouses should have a minimum of a superior single supply. What does that mean? A superior single supply means 2 pumps and 1 tank. And what we have to the left here is it's actually got 2 tanks in there. That's called a superior twin supply, where you've got half the capacity of the 1 tank split into 2. So each of these systems will have 2 pumps, and only one of the pumps can be electric. One has to be electric, and the others have to be diesel. Or you can just have diesel pumps, like we've got in the pictures to the left. Okay. So the tank sizes seem to be rather large. So the reason for splitting into 2 is because it can be more economical to have 2 tanks rather than one big huge tank. The ones on the left are 562 cubic metres each. So there's over 1 million litres of water there. And if you're combining both of the tanks, it would take off a huge surface and it'd be quite high too. This one in particular was next to an airport, so we were limited to the height of the tanks also. Okay. But it's not unusual to 3 half duties, where 2 of the pumps in operation will give you the duty of 1 of the pumps. It's also, as I say, not unusual to have over 1 million litres of water in a warehouse system. This is your typical pump house arrangement, where you've got your tank, you've got some dead water at the bottom, some freeboard at the top, so you get effective capacity. The suction pipe comes along into your pump, that comes up and then comes down to your ICV, which is your installation control valve, and that goes to the system. Now the pump house works, you've got the big pump, which is your main pump, and your backup pump. They're the pumps that are crucial to work to operate the system. But what you may have in the system is small pressure drops due to airways, etc., maybe a small leak underground main. And you've got a jockey pump in there which maintains the system to stop the big pump kicking in for small leaks. Okay. And then at that point you've got a test return back into the tank so you can test the flow and pressure of each pump. Okay, so that's generally the schematic of how any sprinkler pump houses operate. Now we talked about the ICVs. So what you tend to get in warehouses is ICVs such as this. So you may have a 200mm installation control valve down to 6 inch and possibly 4 inch for the rack systems. Now each type of system is limited to size. Okay, so for one control valve feeding a roof area, it can cover up to an area of 9,000 square metres. One control valve feeding a set of racks can cover 2,000 heads. Installation control valves have a bypass arrangement so that the system can still be live during sprinkler servicing. Okay. Now that's you keeping it live. Then you also need to monitor the system to make sure that nobody's shutting the valve. You need to know about it. So you need to monitor a sprinkler system. And the picture on the left is a standard sprinkler monitoring panel. So the following should be met. Healthy signals should be green. So if everything's healthy on that panel on the right, all the signals will be green. If you've got a fault signal, it would be amber. Okay. Now everything basically is a fault, except when it's a fire. So fire signal should be red. So low fuel and water levels. So that's basically a fault signal, so that would come up amber. All valves that can affect the operation of a sprinkler system should be monitored. Now they should be amber signals. Pump house temperature should be monitored also, amber. Trace heating and lagging, if there's any, that needs to be monitored. That should be amber. Pressure and flow switches, now that would be a fire fault because what it's doing is it's detecting flow of water. So if you get flow of water, sprinkler head is activating instead of a fire. Pump running signal again, if the pump's running, it's a flow of water. You then get a fire fault. Okay, power not available would be a fault signal. And trouble at engine, basically fault with the pump controller, again would be a fault signal. And that would be for most of the signals. There is a little bit more than that. You would need to check with your sprinkler consultant and your sprinkler installer, and they'll tell you exactly what you should be doing. Okay, so you've installed your system. Everything's you're happy with it, it's going to work in the event of fire. But like anything, you need to maintain it. If you don't maintain your system, you're leaving yourself open, especially when you come to big diesel pumps. Big diesel pumps, if you can imagine, the engine in them's like your car. If you don't run it all the time or once a week, it could seize. And you don't want your diesel pump seizing when you've got a fire. Your place is going to burn down then. So you ensure your system is tested and maintained by a third-party listed company to ensure competency. Systems should be checked and tested. So on a weekly basis, pumps should be run, pressure should be checked, and levels should be checked. Monthly, check the system for damage, also run your weekly tests. Quarterly, you need to do the weekly and monthly stuff. You test all your flow switches and pressure switches and maintain the installation control valve. So that means basically opening it up, giving it a good look, cleaning it if possible. Biannual service, you need to service the pumps, you need to drain and clean out. You need to drain and clean out the installation control valves. Make sure they're free from any dirt or rubbish, etc., etc. Annually, third-party inspections, okay, and that should be an independent person that does that. 3 yearly, inspect the tank with a drone, drain if required, clean out, and then change the gaskets in your ICVs. 5 years, you want to flush your underground main, inspect your multiple jet controllers if you've got any, and also if you've got any, you need to then inspect a certain amount of your dry pendant drops. You tend to get them in freezers. Okay, every 10 years, drain your tanks and clean them out. Every 25 years, you're then looking at stripping out your heads and pipework for inspection. A certain amount of that needs to go to an independent laboratory for that. You then flush the entire system and give it a 10-bar pressure test. Okay, maintenance should be carried out in accordance with the installation standards. So whatever it was installed to, it should be maintained to that FM, NFPA or BSEN 12845. Now always check with your insurance company what the maintenance regime is, because they might want more or less. It's down to them. There is actually a pack coming out on the FPA website, and the insurance will be able to give you it too, which tells you exactly the full list of inspections that have to be carried out on your system. What I've got on the screen here is only a snapshot. So hopefully that was interesting, and if you've got any questions, I'll try and answer them the best I can. Thank you.
Thank you very much, Alan. Now, before I invite our panelists to rejoin us, I can confirm the recording of the webinar will be available within the next week, and we will send you a link to it. So I would now like to welcome back Ian, Tom, Ian, and Alan, all of whom are here to respond to a few of your remaining questions. and I know that I would like to thank you all so far for your input. Now, Salish Palmer asks, I assume the BSA lobby government on this issue. What is the response from government on your work? Tom, I know you'd like to respond to this.
Okay, so I think it's fair to say fire safety is probably high on the agenda of government right now, for tragic reasons. Previously, it hasn't been so, I would say. But what I would say now is there is an opportunity based on our lobbying to sort of create change. There's a technical review going on of approved document B, which is going to sort of run over a number of years. As part of that, there is the discussion about what to do about things like purpose groups. So is it a warehouse? Is it a factory, as Ian Goff mentioned? A discussion on compartment sizes and what makes sense. I think that's the opportunity for us as the BSA to use the research that we've done and the information that we've collected to create pressure for change. We're not alone in that. You know, we work with organisations like BAFSA, the Fire Sector Federation, the NFCC to push that agenda, and we all see the same thing, that some of these huge compartment sizes do not make sense. And if we're to pursue a route that calls for large compartment sizes, the only way to sensibly do that is through the use of automatic suppression, principally sprinklers.
Thank you. Does anybody else have anything to add, or shall I move on? Okay. Troy Player has a question about tanks. Where is the requirement for a sprinkler tank inlet stated? I know there is an LPC rule which states the need for an inlet connection between the pumps and control valve sets in case the on-site water supply is compromised, but filling the tank would not help in this scenario. Would somebody like to address that?
Yeah, I'll address that. Yes, the rules state that in schools there should be a breach and inlet valve between the sprinkler pump and ICV. But not only that, there's a new rule out that all sprinkler systems from November last year also have to have the same breach and inlet valve, but it has to be between the sprinkler pump and ICV. It's very unusual to see the breach and inlet fill in the tank anymore because these rules are in place. Okay.
Thank you, Troy. I hope that answers your question, Troy. For everyone to have a go at this one, Bart Forster asks, what is the general consensus is there with regard to interaction of smoke extraction and sprinklers? Your thoughts, Alan?
Not a bad thing. Basically, smoke extract fans take the smoke away from above the fire, and it's the smoke, the heat in the smoke that actually activates the sprinkler system. So what should happen is that the smoke extract should only be opened once the sprinklers have activated. So from a flow switch, etc., to a panel, and then open up the smoke extract fans. Smoke extract fans have to be left shut until the sprinklers activate, or it will compromise the activation of the sprinklers.
Thank you. I think, Tom, you wanted to say something on this subject too.
Yeah, I think this is one of these discussions that's gone round and round and round. As Alan said, it's no surprise if you have a device that's sensitive to heat, like a smoke vent and a sprinkler head. If you put them in the same place, they're gonna be sort of impacted. If you open the vent at a certain time, or if the sprinkler operates at a certain time, it can stop the other working as effectively as it should. What I would say is there is more research going on right now to look at that very closely, particularly around the use of things like suppression type sprinkler heads. The concern there is we've always understood there to be a detrimental impact of the smoke vent operating first. Now we've probably got more of techniques that can look at that closely to sort of quantify what that is, so that we can give clearer guidance to people over time of how to do it, because in different jurisdictions around the world, there are different approaches to this. So I'm looking at it as a global thing rather than just in the UK. So I think there is more research coming in this space, and I expect that to sort of come to fruition in the next 18 months, and we'll probably see clearer guidance on this issue. But it is very clear that where you've got two devices that depend on heat to operate, that if you put them in the same space, they're going to have an impact on each other. It's just physics.
Thank you, Tom. Do sprinkler systems have corrosion inhibitor fluid added to the water? Asked James Mulholland.
No.
Go for it. No.
No.
There are, James, a straightforward answer to a straightforward question.
Although actually over time we do know that corrosion is an issue for sprinkler systems for their lifetime. It's not something that happens straight away over their lifetime. So people are looking at things like different ways to vent sprinkler systems, take some of the air out that builds up in a sprinkler system over time. People have talked about putting certain amounts of nitrogen into the water to sort of inhibit corrosion over time with sprinkler systems. So there are other ways that people are looking at this, because corrosion, when you have water and metal together, there is a corrosion issue. But technically there are solutions that are being used out there other than putting stuff in the water.
The only other thing there would be, that was the main reason for doing your 25-year maintenance. You take sections of pipe away, get them analysed, and you'll be able to tell with analysing the pipe how bad the corrosion is, and at that point you may need to change huge sections of pipe or effectively redo your sprinkler system. So that's your 25-year maintenance.
Good point. Tom, I know you want to respond to Brendan Wheeler's question. What fire growth rate would you consider appropriate in a data warehouse building? But anybody else who wants to add to that answer, please feel free.
Yeah, it's a fantastic question, and it's one of those things we're often asked, not about data warehouses, but I guess it's a basic principle. You've got to look at what is actually the hazard within the building to quantify that. There is no general answer to something like this. When you say, it goes back to something Ian Goff said originally, and Ian Cox followed on. When we say warehouse, it conjures a different image in everybody's minds, and you really do need to focus on the hazard. Just as Alan said, when you come to sort of design a sprinkler system, you've got to really closely look at what the hazard is and design the sprinkler system for the hazard, otherwise it won't work. So for something like this, as a data warehouse, really what's the hazard we're talking about in the data warehouse? Because when you say that word to me, I can think of everything from an oil-cooled system for computers through to plastic screening that's for ventilation, and the hazards that they generate are completely different. And therefore, the fire growth rate that I will see in that building is completely different, and it may be localized. So I think it goes back to that sort of principle about fire engineering, really be specific about what the hazard is, because that's what you need to design for. Similarly, I think somebody else asked about mixed goods in a warehouse. How do we deal with that? Again, it's the same principle. You can either design for the highest hazard that's stored in the warehouse and design everything for that, or you have to partition goods up and say, well, I'm only going to store something like aerosols in this area, provide the appropriate protection, and only put aerosols there. Or if you've got lots of flammable liquids, again, partition off part of the warehouse and only put the flammable liquids there. Otherwise, having a totally flexible warehouse that you can store all sorts of nasty things in, from a fire protection solution point of view, is possible, but it's going to cost a lot of money. So it might not be feasible financially. I'm not sure if anybody else wants to say something on that one.
I think, Ian, unfortunately, you might have an issue with your microphone because we're not hearing you. We'll leave you to try and get it back on, and I will come back to you on that answer and ask Alan to address a question from Jason Finn, which opens up another view on the subject of sprinklers. Is it a requirement for schools under BSEN 12845?
Is what a requirement for schools?
Sprinklers, I think.
Sprinklers, I think.
Sorry, missing word.
I think it all depends where you live in the country. I know that in Scotland. We've been putting sprinklers in schools since 2004. And it's now a requirement, building standards requirement since 2010. In Wales, it was January 2016, they had to put sprinklers in schools. It's not actually a requirement in England or Northern Ireland at the moment, but it all depends on, again, the fire engineering approach.
Yeah.
So, in my view, they should be put in every single school, because it's not just about protecting the building, it's about protecting the education of the kids. But I think we covered that in our previous webinar, didn't we?
Yes, indeed. And in fact, anybody who's interested in the subject of schools, we do have a full recording of our webinar from March. So please go on to the BAFSA website and you will find it on the home page. Ian, do we have you back?
I think so. Can you hear me?
Jolly good.
I was so concerned with muting it earlier on. Something went wrong there. But anyway.
Data warehouse, you had something to say.
Yeah, well, what Tom said something that was quite useful in relation to mixed risks, mixed hazards in buildings. This is particularly a problem for many people dealing with recycling centres. Is when you look to put sprinklers in those types of buildings, there are so many areas that could be quite high hazard and other areas that are low hazard. And I've not got the answer to the question, but I just flag up that because there are a lot of people out there looking at these properties. Fire and rescue services want to see more fire sprinklers in those buildings, but it's not always easy to design the correct system or the system that's an efficient system with the amount of water necessary. So I say it's not an answer, but it's just to flag up a common current problem.
Thanks, Ian. Ian Cox, you'd like to say something else on schools?
Alan's covered the other areas. The approved document B specifically refers to BB 100, and that in turn refers you to a risk assessment tool, which is widely misused and gamed, to be honest. It's now under consideration, and the government are considering whether or not they should water it down or remove it or change it. But it's important, I think, because it's one of the few times we've seen property protection actually enshrined in regulation. Up till now, it's all been about life safety. Way back in the midst of time, property protection was part of the life safety requirements when we go back to post-war building studies and the like. But it actually envisaged most schools should have it in England. Only very few wouldn't be sprinklered. And the premise was that the school should be operational within 24 hours. So it wasn't only the reference to property protection, which is important, but it also gave you some parameter about how well you should protect that property, because it's a community asset. They wanted it back on the run within 24 hours of the fire.
Thank you. That's valuable information. Thank you, Ian. So Edward Lum wants to know, what is the lifetime of a sprinkler system? Answers, please.
I've seen sprinkler systems 50, 60 years old, but it all depends how well they're maintained. It's like your car, it'll run for a longer if you maintain it properly. If you don't maintain it, it'll not run so long. So every 25 years you should do a major overhaul and check it. But yeah, I've seen quite old sprinkler systems.
I'll add something, Wendy.
Thank you, Ian.
Just to add to that, BAFSA has been notified, it was a couple of years ago now, of a sprinkler save in a factory in Manchester, and the sprinkler system was 90 years old. The sprinkler head operated and put the fire out, so they've quite a life.
Indeed. I think we've got time for one more question that's come in from Rob Jenks. Okay. Change of owners was mentioned along with use of buildings. What, if anything, has been recommended about how this is best managed? Ocado is an obvious example of the WCS for not adapting. FRS liaison would be key, but if we are unaware of a change of ownership, this may be difficult. Your final thoughts, please, gentlemen.
Well, I suppose I'll kick off, Wendy, because I mean, we may be talking about legal responsibilities there. Of course, the fire safety order deals with responsible persons. That may well be the owner, but it's more than likely to be other people as well, because I think there's still always a responsibility borne by the owner. Just something to explain a change from the previous legislation. The old Fire Precautions Act dealt with owners or occupiers. That has gone with dealing with responsible persons. But there could be more than one responsible person. And it would be up to, if you like, the courts, perhaps, and the enforcing authority at the time to deal with who is responsible. Now, when there's a change of ownership, that doesn't necessarily mean there's a change of perhaps the management of the properties. So it's down to the fire risk assessment and who is the responsible person in law. Insurance, of course, is another matter, and insurance has a significant influence on the protection of these buildings because the insurer is dealing with the property protection. And I'll perhaps hand over to somebody else that might add to that response now.
Yeah, I think in terms of change of use, I think one of the things, when we talk about specifically about warehousing, one of the things we have to realise is there are a number of buildings out there that start off life, they might not have been a warehouse or thought of as a warehouse when they were created. And people will move into them to use them as warehouses. And they have changed the use of the building. Sometimes that is something that should be notified and is done, and therefore people can take account of that. And sometimes people do not do that. And then it's up to what other processes that are in place to sort of to check. Ian's right. One of the people that normally gets notified if somebody moves into a property would be an insurer, but it would depend on how active that insurer is in sort of looking at that situation to give advice. But nobody should escape the fact they have a legal duty to sort of assess the risk. And if they've changed the building or done something in the building to change the risk in the building, they have to assess it. And they can't get away from the idea that they have that duty to sort of do that and take appropriate actions based on the risk within the building. We all like to think there is a safety net, but the premise that we've built a lot of our legislation on is around people being responsible for their actions, and the legal framework is there to sort of pick them up should they sort of transgress. It's not about people being allowed to do certain things. There's a different sort of setup. I know we'd like it to be in a certain route so we can ensure that everything happens correctly. That's just not how it works, unfortunately.
Thank you very much, and thank you for this very interesting discussion we've had. I'd now like to thank Alan, Ian, Tom and Ian for their valuable contributions to this, our 5th BAFSA seminar. If you have any more outstanding questions, you're very welcome to send them through to info@bafsa.org.uk. Thank you to everyone who joined us today. We hope you found it a valuable learning experience. We will be announcing more seminars later in the summer and hope you will choose to join us again. Meanwhile, goodbye and stay safe and well.